Okay, so today what we're going to do is cover the one-to-one property. There's already a video. It's the 5.1a video where it explains graphing these functions. This is what the general graph of an exponential function, the shape it takes on. And again, what you can do is a t-chart, just plug in values for x and then create your graph. And this was in the 5.1 video. Now, when I did it in the video, example 1, I plugged in a whole bunch of points. However, what you need to remember is there is a horizontal asymptote here. So plugging in more values really isn't going to help you, more negative numbers, because it's just approaching 0. And those fractions are going to keep getting smaller and smaller. So generally you can get away with plugging in 3 numbers, a negative, a 0, and a positive number. All of these graphs were in the 5.1a video. If you did not watch that video in class, if you were absent that day, then you need to make sure you watch the 5.1a video and complete the notes and submit your completed notes to Canvas. So where I'm going to start today. Now also memorize the shifts for the graphs. Just remember it's a vertical translation when something is being added or subtracted to the base. Horizontal is when something's being added or subtracted to the exponent. And then a reflection, when there is a negative sign in front of that base, it'll be reflecting across x. If it's a negative sign in the exponent, reflection across y. And then you also have your vertical stretch and shrink and your horizontal stretch and shrink. And these were the shifts. So now remember E, just like pi, remember pi from geometry is approximately 3.14. That would be the approximation that generally you use for pi. For E, it's the same thing. It's got a value. And there is a button on your calculator. But if you're not using a calculator, you can approximate E to be about 2.71. Now, in the end of these notes, there are some formulas. And in order to use and find values using those formulas for interest, we'll be using our calculator because we're going to be using the full value of E. So just know E is a number. It's not a variable when we're talking about the interest formulas. Here's what we're going to talk about today. It's called the one-to-one property. You might also see it referred to as called the change of base. So here, when A is greater than 0 and not equal to 1, and A is our base, if you have the same base, then your exponents, to solve for a missing exponent, you can set the exponents equal to each other. Now, when it's possible, always try to change the larger base to a power of the smaller base. And then also one other fact to remember is that anything raised to the 0 power is going to equal 1. And what this statement here says, for example, is if I have 2 to the x power equals 2 to the 3rd power, if the bases are the same, that's what the a's were, and notice my bases are both 2's, then to find that value of that variable, I just take the exponents, the x and the 3, set them equal to each other, and x equals 3. So this is what we're going to be doing. Now, one other thing to remember is when you have a negative exponent, remember a negative exponent does not make the number negative, it makes it a fraction. Also remember, if you have a fraction exponent or a rational exponent, remember this is actually saying find the square root of 4, and then this answer would be 2. So remember, rational exponents are roots, and negative exponents turn it into a fraction. Also remember, so in the fraction here, remember the denominator is the root you're finding, and the numerator is the exponent. So if that were a number other than 1, after you find the root, then you'd have to raise it to that power. So let's go ahead and try some examples. Let me also show you, let's say we have 2 to the x power equals 8. So up above here, it said, when possible, change the base of the larger number to a power of the smaller. So I'm going to change this 8, and this is where you're going to need to memorize some common powers. So this is actually, I could change the 8, so it has a base of 2, and 2 to the third equals 8. And now that I've changed them, and they both have the same base, now I just set their exponents equal to each other, and x equals 3. When you're doing these problems, you're going to be able to take that variable and plug it back in, and if 2 to the third doesn't equal 8, then you've done something wrong. So let's try the first example. So I want to try to make the bigger number into the base of the smaller one. So I could actually change 9 and make it 3 squared. The same base as the other number. And then rewrite that one. Now that the bases are the same, get rid of the base. So I get rid of the 3's. And now I just set my exponents equal to each other. So 2 is equal to x plus 1. Subtract 1. 1 equals x. And now if you want to make sure that you've done it right, you can take what x equals and plug it back in. So if I take my original equation, 9 is equal to 3 times the x plus 1 power. If I plug in a 1 here for x, 1 plus 1, this becomes 3 squared, and 3 squared equals 9, so I did get the correct answer. Now, sometimes you may have to see something with a fraction, and sometimes you may have to change both bases so they're the same. Now, technically, I could make 8 into a half, but instead, I'm going to change them both. I'm going to change the 1/2, and I'm going to change it to 2 to the negative 1 power. It still has this power of x out here. Let me do it in green so it shows up better. And now I'm also going to change the 8 so it has a power of 2. And then this becomes 2 to the third. Now, I have the same base. I now have both sides with the same base, so I can get rid of the 2's. And remember, when you raise a power to a power, you multiply them. So this actually becomes a negative 1x equals 3. Divide both sides by negative 1, and x equals negative 3. Let's say we wanted to check it. So if you wanted to do a check, you're going to take the 1/2 to the x power. You're going to replace x with negative 3. So 1/2 to the negative 3 power. Whenever I see a fraction raised to a negative power, I flip it to the reciprocal, make the power positive, and 2 to the third is 8. So it works. So my recommendations to you, I would highly recommend that you memorize, for example, that 2 squared equals 4, 2 to the third equals 8, 2 to the fourth 16, and so on. And then maybe the same thing for the 3's. 3 squared is 9. 3 to the third, 27. Do the same thing for the 4's. Some of the beginning smaller numbers. I'm not going to give you something huge when you're not using a calculator. Also remember that the fractions, the 1/3, this is equivalent to 3 to the negative 1. Or 1/9 would be 3 to the negative 2. So be able to recognize these so you can solve these problems rather rapidly. Let's try number 17. So for 17, again, I'm looking to change this 8 so it has a base of 2, so that they're the same. So again, I could change the 8. Its equivalent would be 2 to the 3rd. And then I'm going to rewrite the other side. Now that I have the same base, I can get rid of the 2's, and I set the exponents equal to each other. So 3 is equal to 2x minus 1. We go ahead and add 1 to both sides. 4 is equal to 2x. Divide by 2, and 2 is equal to x. And again, you can always plug it back in. If it doesn't equal 8, you've done something wrong. So we're plugging it into the 2 raised to the 2x minus 1. Put in a 2 there. This becomes 4 minus 1, which gives you 2 to the 3rd, which gives you 8, which is what you were looking for. Next one, fractions. But again, we're going to change it to a negative exponent. So for this one, whenever I see a fraction, I'm going to actually change them both. I'm going to change the 1/3 to 3 to the negative 1. And I still have that raised to the negative x power up here. I'll do it in black so it shows up better. And then I have the 27, and I'm going to change that to 3 to the 3rd, because 3 times 3 is 9, times 3 again is 27. Now that I have the same base, get rid of the 3's, and now you're going to take the power to the power here, multiply the negative 1 times negative x, and this gives you positive x equals 3. So x equals 3. Do the same thing on 19. Change the 1/3 to 3 to the negative 1. Still has the power of x from the original problem. Change the 81. This is actually 3 to the 4th. I have the same base now. Get rid of the 3's. And now again, power to the power. This becomes negative 1 times x, which gives you negative x, or you could leave it as negative 1x. Divide both sides by negative 1, and x equals negative 4. You don't necessarily have to show this. If you want to just multiply it and put it in as negative x, you can. All right? But again, we never want to solve for a negative variable. We have to divide by a negative 1. Let's try the next one. Again, we're going to try to make that 8 into a base of 2. So I can change this 8 into 2 to the 3rd. It's still got the x minus 6 power. And then this side has the x plus 4 power. So again, my bases are the same. Get rid of the 2's. And now you're going to work with the exponents that remain. So x plus 4. Now, on this side, you're going to distribute the 3 to the x minus 6. So 3x minus 18. Drop down the x plus 4 side. Get all your x's to the left and your numbers to the right. So subtract. And it doesn't really matter. I could have also moved the x to the other side. And then now I'll add the 4, or subtract the 4. Negative 2x equals negative 22. Divide by negative 2, and x equals positive 11. Next one. Again, we need to make the bases the same. So we're going to change the 8, so it's 2 to the 3rd again. And then this side had 2 raised to the 3 minus x power. Get rid of the bases that are the same now. And now set the exponents equal to each other. Go ahead and subtract the 3. Negative x equals 0. Well, if I divide 0 by negative 1, it's still just 0. So 0 can be an answer because if I plug it in up here, 2 to the 3 minus x, if I plug in a 0 for this x, it just becomes 2 to the 3rd, which equals 8, which is what I was looking for. The next one, we're going to change the 25. So it has a base of 5. So this will become 5 squared. This side is 5 raised to the 2x plus 1. Once the bases are the same, get rid of the 5, that common base. Set the exponents equal to each other. Solve for x. Divide. And x equals 1/2. So in addition to x being 0, it can also be a fraction. Now let's look at e. Now we're still not using a calculator. All we're doing is making the bases the same. And if you notice, they both have a base of e. So just get rid of that base of e and work with the exponents. So I'm just going to set 4x minus 1. This 2, power to the power, multiply it. And now get your x's together. Negative 1 equals negative 2x. Divide both sides by negative 2. Negative 1 divided by negative 2 is positive 1/2 equals x. So even if it's got a base of e, we're not using a calculator, we're making it have the same base. And the base was e. What's nice about all these examples, remember, you can plug back in the value of x you get, and if the two sides of the equation are not equal, you've done something wrong. So let's go ahead and try the next one. Again, we need to change them so they have the same base. Now, in this particular problem, I can't make the 27 have a base of 9. I actually have to change both bases so that they're the same. So I'm going to change the 27 into 3 to the 3rd. I'm going to change the 9 into 3 squared. Now, I still have the powers that are there. And now that the bases are the same, get rid of the 3's. And now, power to the power, we need to multiply these. So 3 times 4x and the 2 and distribute it to the x plus 1. So I end up with 3 times 4x equals 2 times the x plus 1. I'm going to multiply and get 12x. Distribute 2x plus 2. Subtract the 2x. 10x equals 2. Divide by 10. And x equals 1/5. The next one. Make the bases the same. This one I only need to change the 4. I'm going to change the 4 into a 2 squared. Remember, it still has the x minus 2. And then the other side is already set for me. Now that I have the same base, get rid of those 2's. And again, the power to the power here, you need to distribute the 2 to the x minus 2. This side you just leave alone. So 2x minus 4 equals 3x plus 3. Group your like terms. So negative 1x minus 4 equals 3. Add the 4. Negative 1x equals 7. Divide by negative 1. And x equals negative 7. So x can also be a negative number. So x can be an integer, and it can also be a fraction, or even it can also be 0. Let's try the next one, and then we'll do 3 more. Last one on this slide. Oh, we got e again. Now, instead of working with this as a fraction, I'm going to turn it back into an e. So I'm going to change 1 over e. It's a fraction, so I'm going to make it e to the negative 1. And then it still has the original negative x. This will become e to the negative 2, but it still had the x plus 1. Get rid of the base e now. And now multiply your power to the power. So it's negative 1 times negative x. And then negative 2 distribute it to the x plus 1. This just becomes positive x. This becomes negative 2x minus 2. We'll go ahead and add the 2x to the other side. 3x equals negative 2. Divide by 3. And x equals negative 2/3. And remember, e is just a number. And we're just changing it so it has the same base. All right, this one, radical. So again, I need to make these both have the same base. So I'm going to change the square root of 2 so it has a base of 2, but I'm going to make it have an exponent of 1/2, a fraction exponent. It still has the x plus 4. And then I'm going to also change the 4. So it has a base of 2. I'm going to make the 4 2 squared. And then put the x there. The bases are the same. Get rid of the 2's. Multiply. So here, bases are the same. So I need to distribute the 1/2 to the x plus 4. And then the 2 to the x. So now I get 1/2 x plus 2 equals 2x. Now, I don't want to work with fractions, so I'm going to do like I did at the beginning of the year, and I'm going to clear my denominator. So I'm going to multiply my whole equation by a 2 and clear that fraction. You can leave it and work with the fraction. So I can go ahead and distribute it, and then I get x plus 4 equals 4x, and now it's a lot easier to work with. So subtract the x, 4 equals 3x, divide by 3, and x equals 4/3. If at this step you did not want to clear the fraction, then what you would have done is you would have subtract the half, and this works as well, and get 2 is equal to, and I could change this to be 4 over 2. So then this becomes 3 over 2x. And then you would have to multiply by the reciprocal or divide by 3/2. And then what you end up getting with is the same answer I got. So you could also leave it the fraction. It just makes it a little bit easier when you go to solve. It's totally up to you. So the last 2 examples are what we've already covered back when we did that prerequisite chapter. So way back at the beginning. For this one, notice there's no way I could make both sides have the same base. So what I'm going to do is instead, I'm going to convert b to the negative 3 to be 1 over b to the 3rd. And then write this one. And now I'm just going to solve this as if it's a proportion. So I'll cross multiply. I'll do 1 times b to the 3rd and then 1 times 27. And I end up with b to the 3rd equals 27. I need to cube root both sides. And b equals 3. Again, what we did at the beginning of the year. I'm going to raise both sides to the reciprocal power. Now, what I can do here is I'm just going to raise both sides to the 3rd power, which will cancel that. So then this becomes 64 equals r squared. And then now I have to square root both sides and plus and minus 8. Because whenever you solve for a variable squared, that's when you put both answers. Now, you could have also done this. You could have taken the original problem, raised both sides to the reciprocal power, and again, that would have simplified this. This would have become just an r. And then what you're doing here is you're doing the square root of 4 and then cubing it. So the square root of 4 would have been plus and minus 2, and then raise both sides to the third power, and that's how you get plus and minus 8. So you can do it either way. Now, I'm probably not going to give you, something super huge, but again, always try to do the root first if possible. Sometimes you can't. Like for example, let's say I gave you x to the 2/3 equals 64. So if you try to raise both sides and do it the first way I did it, raise both sides to the third power, then this is going to be huge without a calculator. So again, it would definitely be better to multiply it by the reciprocal. So here, if it was x to the 2/3 equals 64, then multiply it by the reciprocal, do the square root of 64, and then cube it. Granted, it's still big, but you're only doing 8 to the third power, and 8 times 8 is 64, and then one more time, plus and minus 512. The biggest mistake that everybody made at the beginning of the year and even now, remember, whenever you're solving for a variable squared, or square rooting like that, we need to put plus minus. So homework is 5-1B. Now, the only calculator part of the test is what I'm going to cover on Monday, the interest formulas. So your homework over the weekend is 5-1B.